You want to know about rocks?
Well, there's a science for that.
Hello and welcome back to another episode of The Experiment, where we take your everyday questions and turn them into experiments. My name is Shannel.
And I'm Cathy, and today we're going to talk about the various strength of rocks.
Did you know
What?
that geologists study the strengths of rocks to determine which rocks erode the most?
But what's erosion?
Erosion is the process of natural agents such as wind, water, or snow that gradually wears away at land, soil, or rocks. To help you understand what we're talking about, we're going to pass it over to scientist Sonya and scientist Vanessa.
For this experiment, you're going to need a wide neck plastic container, which has a clip-on or screwable top. You will also need rocks or building material of various sorts, such as this rock that we named John Cena or this little rock that we named Steve. To represent the Earth, we put rocks in a container. To demonstrate the forces that occur on Earth, to help the process of erosion, we shook the container for 15 seconds. After 15 seconds, we would observe our results, and after our examination, we will repeat the process until we would see more visible results. For example, large chunks of the rock are broken off, leaving the rock smaller than it originally was. The purpose of this experiment is to find out which rocks are the best survivors against the forces and collision of other rocks as they erode away. This is supposed to represent what happens to rocks on Earth as time goes by on the geological timescale. So Sonya, which one do you think is going to break up the fastest?
Well, I think that Steve is going to break up the fastest because he is made of more brittle looking material and is much smaller as compared to John Cena here, who seems much sturdier and larger.
I think some of the smaller and brittle looking rocks will fall apart due to the shaking and collision of other rocks inside the container, thus breaking it further down to sediments that can be used to gradually create other types of rocks.
We hypothesize that some of the rocks are stronger than others. For example, John Cena being stronger than Steve because they are formed differently. Steve was most likely a sedimentary rock because sedimentary rocks tend to be the most brittle, while metamorphic rocks are the strongest. First off, we will start off with igneous rocks. When igneous rocks are exposed to the forces of weathering, which is the wearing away of rock, and erosion, which is similar to weathering, but it is when rocks are being broken down by natural elements such as wind, water, or snow, the igneous rocks will become sediments, which are basically rocks that have been broken down. Through transportation, which is the movement of the rocks or sediments through natural causes such as wind, the sediments get deposited into large bodies of water. These sediments are then pressed together with the weight of the other sediments being piled on top of one another, putting the most stress on the bottom layers through the process of compaction. Now, through the process of cementation, the rocks are glued together, creating, over a long period of time, sedimentary rocks. When sedimentary rocks go under heat and pressure that is located within the earth, they become metamorphic rocks. When metamorphic rocks melt due to intense heat, they melt into magma, which is molten rock, located within the earth. The cooling of the magma then creates igneous rocks. When igneous rocks are put under intense heat, they become magma once again. When igneous rocks are exposed to heat and pressure, they change into metamorphic rocks. When metamorphic rocks and sedimentary rocks are exposed to the forces of weathering and erosion, they erode and become sediments once more. And thus, the cycle will repeat itself.
So for this experiment, you're going to need to place all your rocks inside the container. Then you're going to have to put on the top, make sure it's tight, and And then you're gonna shake it for 15 seconds.
When we finished shaking the container, we pulled out Steve and John Cena. We saw that Steve didn't change much, so we decided to shake it once more to see if we could get any more visible results.
Now we're gonna shake it for 15 seconds. Make sure it's really hard. After 15 seconds, you're gonna lift up the top.
Here we see the last remains of Steve. As you can see, it has gotten much smaller and broken into pieces. This is an effect of erosion. And here we see John Cena, who's still really large and intact. This is because it's made of sturdier material and much harder.
In conclusion, since the smaller and brittle looking rocks were broken down into smaller sediments, the more we repeated the processes we took to fulfill our experiment. Just as we had predicted earlier on in the video, our hypothesis has been proven correct that the amount of times the rocks have been exposed to the forces of erosion, in this case the shaking of the container, the more these rocks will break off, creating sediments.
Thank you, Scientist Sonya and Scientist Vanessa, for that wonderful experiment.
Tune in next time where we learn about tsunamis.
Cathy, just memorize. It's so easy.
Wearing away soil, rock, or rock. Okay. Like the video while you're doing it, you can like take off your glasses and you can be like, did you know?
Experiment. Wait, oh my god, I'm blind.
But it's much more brighter now.
I'm blind.
It's strong.
Can we just say for the rock you think is gonna happen?
Okay.
So what? So you're gonna write.
Okay, go.
You want to know about rocks?
Times it.
That's wrong.
6.
You only have a 6:30.
What does this even mean? Which one make high heels and what?
I was recording.
Can I like write it on the rock? Rocks.
Did you know? Did you know?
What? Sorry. Again. Sorry.
Mom, stop singing.
Again.
At the top.
I broke it.
No, I saw these powder looking things on the Vanessa took drugs.
Apologist Sonya for that wonderful